Okay, you're welcome back to Integrated. This is Mathematics. So after a long time, just went after discussing with these with your feedbacks and comments. Just I decided to talk about homogeneous functions. So what about these homogeneous functions? Most of the guys they don't know what about the homogeneous function when they're gonna do even they're gonna solve the differential equations also that's going around the homogeneous function, but we don't know exactly what about the homogeneous function. So let me explain you. Actually, just I hoped by this session to continue because actually it does engineering mathematics, advanced engineering mathematics book. So that's it would be very helpful to you those who are studying engineering mathematics. Okay, so let me explain you uh, uh, as always as usual. Yes, I say this one also. If you have any doubt regarding this section or my previous section, please be kind enough to let me know. Okay. So what about this homogeneous function? Yeah, actually, homogeneous function. A function f of x and y is said to be homogeneous function is in which is the power of each term is same. What does it mean? Let me explain. A function f of x y is a homogeneous function of order n if the degree of each of its term in x and y is equal to n. That's just give me here. Okay. Let me write on that. Proving those here. Our requirement is the coefficient, just like it looks like the polynomial function. That's very similar to the polynomial function, but we have two variables here. We're talking about two variable and degree homogeneous function here. Okay, just pay attention on each of these terms here. When it has been increased, it has been decreased itself. What will be happening for the y? Yeah, it has been increased, just like the actually that's very similar to the binomial expansion. Yeah, but it's not a binomial expansion. Okay, what about the last term? Uh, actually, just like the polynomial function, if this in n degree, you'd have n plus 1 terms, n plus now 1 number of terms. Okay, for you need to have n plus 1 number of terms. What about this one? An, this is the n plus 1, the coefficient of that, the terms coefficient of that. What about the later pi? Okay, so x will be vanished, y to the power n. Okay, it's going like that. This is the homogeneous function. We say the degree homogeneous function. Okay, each of these terms, if you're gonna dignify uh, this distance, you're able to say each of these terms degree is gonna be equal to a little n. Okay, so we may be able to do something like this with this type of homogeneous function. Let me show you. If I'm gonna take out x to the power n as a factor from all these guys, what will be happen? This is just a note. There's a coefficient. Okay, what about this one? Yeah, a1. Yeah, y upon x. What about the next guy? Yeah, I haven't mentioned that one, but it would be like that. Y upon x squared. What about the last guy? Yeah, what about the last guy? Hey, n times here y upon x to the power n. Actually, we're able to say that if I'm going to call this as a polynomial function of phi of y upon x, this can be called such function is a polynomial function of y upon x. Okay, y upon x, keep this in your mind, is a polynomial function of y upon x. So this homogeneous function can be written as f of xy is going to be equal to x to the power little n times phi of y upon x. Okay, so the Euler's theorem, the first equation. Okay, this I'm gonna tell you what about the first equation, and you need to take some time and as your homework, just try to prove it. Okay, just regarding that's revolving around the positive derivatives. That's very useful when you're gonna go forward when you're dealing with some differential equations. Also, it's very profitable. So it's like this. Let me erase this. Okay, let me erase this, and I'm just asking you to prove this at home. Okay, when you're free, just try to do this type of x times partial z, where z is the homogeneous function of x and y variable, which is saying x and y, and the decrease little n, just assume like that. Okay, just assume like that. This is going to be equal to n times z. Okay, show that this is going to be equal to n times z. Okay, so you can do it at home. Okay, you'll be given only these homogeneous function which is in the order of little n, and this we have algebraical equation that's just like the variable which is saying x and y. Okay, so just please try it at home. Okay, so thank you very much for watching. I hope to derive all these Euler's theorems, Euler's equations. Okay, see you in the next video. Okay, thank you.